describe function gives you a lot of information. Okay, so let's understand these are the statistical concepts, what you need to have uh, in your head when you see these numbers. So let's start from measures of central tendency first. Okay, what do we mean by this? So mean, median, mode, these are the three basic concepts that you should understand whenever you are trying to find the central tendency of the data. Why do we find the central tendency of the data? So every data point is like every column in your data gives you a rough, like if you find the central tendency of it, it gives you a rough information of how that column is spreaded. Like for example, price. If I say the average is also nothing but the mean value. If the average price of the cars is 10,000, okay, what this tells you, it tells you that okay, in the price column there might be values like 11,000 or 10,500 or maybe 9,000, somewhere to 12,000, right? You'll get this mental idea that okay, on an average it is 10,000, some values will be higher, some values will be lower. Yes, correct. But typically it will be 10,000. So that's why you ask what is the average price, average salary. Let's say 5 lakhs per annum. So you try to sense like if I read these concepts, if I learn machine learning, what will be my average salary after I try to get uh, placements? Okay, try to give interviews. Yes, so it gives you a sense. There might be salaries that are higher than this, there might be salaries which are lower than this for the same kind of concepts but same kind of skill sets, but on an average this is, let's say, the average salary. So average tells you what is the central value around which the data is spreaded. Okay, is this making sense, everybody?
Yes.
Yes, cool. Now let's take a look at the sample salaries for a campus placement. Okay, say 2 lakhs, 0.5 lakhs, 3 lakhs, 50 lakhs, 75 lakhs. So there were two very bright students who got placed, let's say at Microsoft or uh, Google, and they got huge salaries. Okay, if you compute the average of this, how will you compute? You will sum everything and then divide by the total number of values, right? So the average will still come high. So the average, let's say, this comes as 6 lakhs per annum. You will say, oh wow, the average salary is 6 lakhs per annum, so it's a good deal. But you are neglecting the fact that only a few students got very high salary that are also outliers in the data that has skewed the average. So mean is affected by outliers. Okay. Essentially, if you might have seen this curve, this is the ideal bell curve. Okay. And this is the central value. This is the mean value. Data is spreaded on the left side of the mean value and data is spreaded on the right hand side of the middle value, mean value. If there are outliers, let's say there are certain outliers, then what will happen to the mean value? Mean will shift towards the outliers, because if you sum up the outliers into the same section of values, same set of values, then in the end you are going to get larger number as the average. The average will be inflated, correct? So the mean value shifts over here because of outliers. So mean is affected by outliers. That is the message. So then mean is misleading. What do we use instead of mean? Median. Median says, median is the true central tendency because the steps involved over here is, first step, sort the data. Increasing order, find that value, equal halves. Two equal halves. Giving you a very small example, let's say 1, 2, 3, 4, 5. Okay, 5 values are there. So 3 becomes the median value. Okay, let's say 10, 20, 22, 28, 70. Okay, 22 becomes the median value, the center point. To this side and to this side, center point, to this side, to this side. Maybe take one more example, like 3 this side and 3 this side. Okay, so you arrange the data in increasing order and take the value, value that is basically in the middle and divides the data into two equal halves. Okay, what if I have even number of values? Let's say 1, 2, 3, 4, 5, 6. Then what?
Average of 3 and 4.
Perfect. Yes. We take the average of 3 and 4. This is nothing but the median value. Now, the beauty of median is not affected by outliers. Median is not affected by outliers. So in this scenario also, what will be the median value? Let's count, like 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 values are there. So 4 values this side and 4 values this side. Let's say if I arrange it in increasing order, so 2.4 will come here, 2.4 will come here, 2.3. So sorry. Like this in increasing order. So 2.8 lakhs will come over here. This will be 2.6 and 2.6 will become 2.8. Okay, so now increasing order. So 4 values this side and 4 values this side. I now know that the median is 2.5 lakhs. So the average salary is not 6 lakhs. The average salary is 2.5 lakhs because most of the people, majority of the people are having a salary around 2.5 lakhs. These are the two exceptions that occurred and that increased the average. But if I really want to know what is the average salary, I should look at the median value. And you might have seen some of these colleges now started publishing their salary in terms of median because they know people are educated now and they understand the average can be misleading because of some of the students getting very high packages. So for numeric values you can use median or mean to find out the central tendency, and median is preferred because it is not affected by the outliers. Okay, what about mode value? Mode value is for categorical data. or quantitative data. I should say quantitative data. Because numeric data can also be categorical. So this is for categorical data. So let's say you have gender column, okay, which can be present as 0 and 1s also, or it can be present as male or female also. So whichever category is present more number of times, that is known as mode value. So here mode value is here male, and here the mode value is 1. Okay, whichever category is present maximum number of times. So there can be multiple categories, let's say A, B, and C. So whichever is present maximum number of times, for example, C is present maximum number of times, so C becomes the mode. If there is a scenario like this, 100 times, 100 times, 50, 70 times, 4 categories, A, B, C, D. Then A and C both are modes. So there are two modes. Why? Because both of them are present equal number of times. So this type of data is also known as bimodal. There are two modes, two uh, unique values that are present equal number of times. Okay. Why do we use mode for gender categorical data? Because we cannot compute average. We cannot add all the males plus females divided by the total number, right? We cannot add A, B, C. These are categories. So since you cannot perform an averaging over here, that's why you count, and the counting gives you the mode value. Now, this is central tendency. So what do we look for? We look for the median value for quantitative data, and we look for the mode value for categorical data to understand what is the central position of this data column. Okay, then how the data is spreaded. So we look at these minimum maximum value, okay, which is also the range. Look at variation of the data, variance, and then we look at the standard deviation. So min max is pretty clear. What is the minimum value and what is the maximum value. What kind of data insights it can give you. For example, let's say age column is there, and you are doing the data analysis for age column, and you looked at the minimum and max value. So minimum value came out to be -20, maximum value came out to be 120. You immediately know there is something wrong in the data. How? Just by looking at the age column. Yeah, age cannot be negative, right? Age cannot be negative. So by looking at the range of a particular column, you understand that whether the data is sensible or not, or is there any issue in terms of reading the data. Okay. So min max helps you to take a decision in terms of whether the data looks sensible or not. Okay. And if there are issues, then you treat them. How do we treat them? You basically try to replace them with the nearest logical value that we will learn in the 6th notebook. Okay. What about variance? Variance is important, and variance is linked with standard deviation. Essentially, standard deviation. So, standard deviation is nothing but the square root of variance. But what is variance, first of all? So, we try to understand the variation of all the values around mean value. Okay. How do we compute this? So, taking an example, let's say 1, 2, 3, 4, 5, 6. First six natural numbers. If you take the mean value of it, mean of these six values, it will come out to be 3.5. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6, mean value will be 3.5. So what variation or the variance tries to do is tries to find out the distance between each value and the mean value. So 1 minus 2, 2 minus, sorry, 1 minus 3.5, my bad. 1 minus 3.5, 2 minus 3.5, so on and so forth. 5 minus 3.5, 6 minus 3.5. Yeah. So the fun part is like if you calculate all of this, it turns out to be zero because you are subtracting the same amount as you are adding. So this turns out to be zero. Okay. So what we do to compute the variance, we square it. Okay. This a value that you are getting is nothing but the variation, sorry, average also, divide by 6. This is the variation or the variance of the uh, column or variance of these values. And standard deviation is nothing but the square root of variance that tells you the average. Since this is squared, if I take the square root, then it will be the average distance of every point from mean value. Why would I want to measure this? Average distance, what it is giving me. So it is telling me how close the data points are or how far away the data points are. For instance, take this scenario number A. In scenario number A, or in column A, there are three columns, let's say. In column A, the values are like this. Everything is 10. Plus 10 plus 10 plus 10 plus 10, 50 divided by 5 will be 10. Average will be 10. So average is 10. So if average is 10, so 10 minus 10, 10 minus 10, 10 minus 10 whole squared, everything is 0. So the variation or the variance in this column is 0. So what do I understand from variation? If variation is 0, that means every value in the column is same. There is no variation. Is this making sense? There is no variation in the data. This type of column is not helpful for machine learning. I cannot use it in machine learning. There has to be some variance, okay? Some amount of variance. For example, 10, then 15, 12, 13, let's say 18. So you see the average roughly will come around 14 or 15. Yeah, let's say 14, 14 point something. So the average value is 14 and every value is varying nearby 14. So you understand there is some variation. So let's say the variance came out to be 10 or 15. Like I'm just roughly putting some numbers, okay? Rough numbers. Variation, machine learning. Third scenario, let's say there is too much variance. 10,000, 50, 71. Too much variation in the data. Yes, the mean value will be somewhere around maybe let's say 400 or 500, and the variance will also be high because if if you are subtracting something far away, then it will generate huge number. Like for example, this 6 was 600. So the mean value will also be like somewhere around 100. So 1 minus 100, 2 minus 100, 3 minus 100. The whole variation calculation will explode, right? So if you have a lot of different values and outliers, especially in the data, then the variance will increase. So let's say over here, the variance was 500 roughly. This type of data has too much variance. Directly, what do? We treat it, we treat the variance, treat variance, and then use it. So treat outliers basically, treat outliers and then use it. Okay. Is this making sense? How do you utilize variance? Variance tells you, or standard deviation tells you, how close the data points are from each other in a given column. If they are exactly same, then there will be no variation, which definitely cannot be used in machine learning. You need some variance. If this is too much variance, then also it cannot be used in machine learning. So what you do, you treat the variance, maybe probably remove this 1000 outlier and then use that column. Now, the third type of measure is known as measures of location. Quartiles. Most important measures of location. Quartile says divide the data into 4 equal parts. Okay. How? This is your data. What is this portion? 50%? Yes. Median, or it will be equal to mean if the data does not have outliers. Okay. So mean and median will be same.
Yes.
But practically, like theoretically, it should be median up first. So median is the point that divides the data into 2 equal halves. If I take this 50% and further divide it into 2 parts, 25, 25. Yes. If I take this, further divide it into 2 parts. So these 3 points are nothing but my Q1 and Q2. Q1, Q2, and Q3. So these are known as quartiles. The middle quartile, Q2, is also known as median value. Okay. So these 3 points divide the data into 4 equal parts of 25% each. Why it is important for me to know this? Because if you know in your column, in your data column, that okay, Q1 is this much, then before Q1, you will see typically the outliers over here. This is where the outliers will live. And after Q3, this is where the outliers will live. So I know that Q1 and Q3, in between Q1 and Q3, I have the best data, free of outliers, also known as interquartile range. Okay. If we are dividing the data into 4 parts, let's divide it more. So deciles is similar to quartiles. You just divide the data into 10 equal parts. Okay. Then if I divide the data into 100 equal parts, then what do I get? Percent. This needs no introduction. All your life you have been running around to get a better percentage since class 10th onwards, I believe. Right? So percent, like take the data, divide it into 100 equal parts and see how many parts did you achieve. Okay, so percentage. There is something called percentile, which is a relative scoring mechanism. What does this mean? So take the example. Let's say you've taken the cat. Cat score is published in as percentile. So cat score typically happens as a relative mechanism, relative scoring mechanism. So let's say the exam was of 100 marks and you scored say 70 out of 100. This means 70%. Simple enough. I divide the data into 100 parts and then check how many parts did I reach. So 70 parts I have reached 70%. Percentage percent is absolute score. But if I say percentile, then I am also taking into account how other people have performed. So if I say you got 70 out of 100 and you have scored 95 percentile, then it means you have scored more than 95% of the students who took the exam. So if let's say if 1,000 students took the exam, then your score 70 is better than 950 students. So 950 students scored less than 70 marks. So it's a relative score. Like you take into account how other people are doing, and then you publish a score which is in terms of percentile, in which percentile you are present. So 95 percentile means since you scored 70, you are better than 95%, 95% of the people who scored, who took the exam because they scored less than 70. So these values is something you see all of a sudden. Now probably it'll start making sense over here in the output. If you see now, price column, how many number of values? 1436. What is the mean value? 10,730. What is the minimum value? 4,000 and maximum value 32,000. Right? Now, if you compare the mean value with minimum and maximum, for sure you'll start understanding that okay, there are certain outliers. The maximum value is too far away. How do you know? So you look at the third quartile. So this is the first quartile, 25% mark, Q1, Q2, which is nothing but the median value. 9900 is the median value. 75% is the Q3. So if the Q3 and the maximum value, they are having a huge gap between them, 11,000 versus 32,000, that tells you that there are outliers. And in fact, when you plot the data going further, you will see, I'm just fast forwarding it to show you. When you plot the price column later on, you will realize that, oh, there are outliers here. So this graph is actually really helpful and it tells you everything in one go. What is the minimum value? Around 5,000, so 4,000 something over here. What is the maximum value? Around 30,000, so let's say 32, 33,000. You get a rough estimate, rough idea. Then what is the middle value? So there are 400 such car prices, which are somewhere around 10,000. So you get an idea, oh, the average will be somewhere around 10,000. So all of this information via graph becomes so obvious that you are printing it here. Yeah, the mean value, the median value, etc. Now, so look at age. Mean value 55, standard deviation 18, minimum value is 1. So, minimum value and the first quarter. You see a huge gap? That means 1 is an outlier. Okay, or this side there is an outlier on the left hand side. A lot of cars are with age 1. Hmm? Similarly, you see the 75 and max, there is not much of a gap. So there are no outliers on the positive side, on the right hand side. 50% is the median value. Now you will notice if you have outliers on the left hand side, the mean value over here is less than the median value. Mean is shifting towards the left hand side outlier. So mean value 55 is low as compared to median. And in this scenario, since the outlier is on the right hand side, the mean gets shifted towards the right hand side. So here the mean value is more than the median value. So in terms of graph, you can imagine it like this. So here you have the outliers, outliers. Here in this side you have outliers. Okay. If your outliers is on the right hand side, this is known as positively skewed. If the outliers on the left hand side, it is known as negative skew. Okay. So if your outliers are on this side, your mean value will shift towards the outliers, and then the median value will remain here. Median, and this is the, I'm sorry, yeah, median, and this is the mean value. So mean value shifted towards the outliers. Then here the median value will remain here also, and the mean value will get shifted towards the outlier. So mean will be greater than the median if your outliers on the right hand side, and mean will be less than median if your outliers on the left hand side. So all of these statistics can be seen over here for all the columns, but not necessarily meaningful. Like for example, HP, all of these statistics may not mean anything to you because it's a category. For metallic color, all of these statistics, although Python is computing it because it has got a number in it, but these does not make sense because it's a category. So for categorical variables, does not make sense. So that is why for you, it's very important before doing any kind of analysis, you understand clearly which column is what. Okay.